Let's see another binary search tree problem. It is construct binary search tree from Preorder Traversal. It's a medium level problem. So the problem says that the Preorder Traversal, that's array, is given, and based on this we need to construct binary search tree. So we need to find the pattern by seeing the data here. Like if you see this pre-order data here, and if you see the root is 8, so this root is 8, and if you see in the left side, we know the binary search tree has all the items in the left side is lower than this root. So if you see here also, there is a 8, and this is the given 8, and that's the root, and the left side all the items are smaller than 8. So if you see the 5.7, so 5.7, that's a smaller than 8. So that means these numbers go to the left side. So that's the pattern we need to analyze. And another one is after 7, if you see the 10, 12, that's a 10, 12 is in right side. So this number must go in a right side. So that's the pattern we need to understand. So if you know this pattern, then it's very easy to write the code. So based on this analysis, let's write code. We'll put the 8 in the root, and then we'll put these numbers in the left side and this number in the right side, and we do the recursive call, and that's the easy solution. So let's do that. Okay, so I can check in the beginning, like here, if this preorder length of preorder, if the length of preorder is 0, if there is there's nothing, then I can return nil. Another case I can check if length of preorder is 1, just we have this one item, then I can just return a new node having this in a value. So return, it's a tree node, and val is equal to preorder 0. So we can return this, and we need to write the code for another scenarios, like where this length is greater than 1. Then in that case we need to find out like from the pre-order, we need to find out which number goes to the left side and which number goes to the right side. So what I can do, from here I can check the number is less than this 8, number is less than 8, 7 is also less than 8. I keep incrementing some pointer, and from there, so I'm just going to maintain I pointer, and I'll put it here and then check if this is smaller than this 8. I increment the counter. In the same way, 7 less than 8, increment the counter, so I will be here. So in a root 8 goes, and in the left side 5 to 7 goes. So I is here. If I say the I, like from 1 to I, then it will take the 5.7, because 10 won't be inclusive. So it will take 5.7, and then from in the right side I can put from the I to everything from there. So let me find out this boundary here. So I will just say I is equal to 1. I can start from this 5, and then I can check if I is less than this pre-order list, whatever this pre-order. So we need to check that it's a less than that. So pre-order, and I can check the pre-order I. That means the I is at 1, so 1 is 5, so this 5 pipe is less than 8, so it's less than pre-order 0 I plus plus. So I will do that, and in this case, the pipe is less than 8, 1 is less than 8, 7 is less than 8, and in this case I will come here. So we know the I is here. Now next thing is, okay, but we need to make this node. I can say this is the root, and root has the pre-order 0. So if in this case the 8 that is in the val, so we need to put that in a, we'll put the value in the left side. So what I do, root dot left, and I can say from the pre-order from 1. So I will call this function recursively. So let's call this function recursively, and I can put the item preorder 1, that means from here to I. So I, if I say the I, because I is at 10, so if I say the I, then it will take 5.7. So from 1 to I. So that goes in the left side. In the similar way, we need to put the item in the right side. So in the right side, and in the right side I want to start from here, so I to till end. So I can say I to end. So if I do not put anything, that goes till end. So that's the easy solution. Let me return root, and then again we dry run this program and see. Root dot left, this one bracket is missing here also, here also. Oh, 2 typo. Okay, that got accepted. Let's come to the description, and again let's dry run this. So let's take this as an example, and let's start from here, 8, like from here. So it's a length is 0, no, length is 1, no. Then we'll come here, and then we'll create the root, one node will create, and in this node has the value 8, and then we'll find the I position from this pre-order and the I. So we found the I position here, this loop, and then we'll call BST pre-order in the left side. So when you call the left side, again we call this recursively, and in this time we are passing only these values because we already found the I, and here pre-order 1 plus I, so we pass this value, and the write is pending. Again we call, so if in a 5, and then for the left side we call this one, and then from here if it call again, then we'll come to the in a root value, it will be put the 5. Again we'll call 1, that's a recursive call, again it will put 1, and again we'll got left side, so left side is 0, so that's a return nil. So for this node that will be nil. And again right will call, and for this right value will be nil. So left is done. So for the 5, this is done. So for the right portion, again this right call will get call, and 7 will put there. So in this way this recursion call happens, and will successfully will be able to construct this binary search tree. So the problem is very easy. So I think you can figure out this in a Java code also. There is not a complex logic, so I will not add this code this time. So that's all for now. Thank you.